In the previous video, I briefly explained a household 2-voltage electrical installation. In this section, I will talk a little about light dimmers, as well as electric motors used in household appliances. As for light dimmers, we will first examine how the brightness of a light source can be dimmed, which for simplicity will be an incandescent bulb using a rheostat. We have already talked about how a resistor decreases the electric current flowing through a circuit. A rheostat is a resistor which can be varied, since it has a slider which moves from one end of the resistor to the other. To illustrate this, let's think of a simple circuit with a light bulb and a rheostat in series. When the rheostat slider is at end A of its stroke, the electric current will have to go through the entire resistor, thereby reducing the amount of electric current flowing through the light bulb. When the rheostat slider is at the end B of its stroke, the electric current goes directly through the light bulb, which turns on fully. As you may have already noticed, at any intermediate position of the slider, the brightness of the light bulb will be proportional to the amount of resistance the rheostat has in series with the light bulb. Although this system works and is quite simple, it has a serious drawback. To reduce the brightness of the light bulb, it is necessary to waste energy lost to the resistor of the rheostat in the form of heat. To explain this, let's assume we have an alternator which produces 100 volts AC. Also, that the light bulb has an internal resistance of 50 ohms. And lastly, that the rheostat in its maximum resistance position has an internal resistance of 50 ohms. When the rheostat allows all the energy to go directly to the light bulb with its slider at the B position, the bulb will be receiving the full 100 volts applied to its 50 ohm internal resistance, and the current going through the bulb will be 2 amps. According to Ohm's law, the light bulb will be dissipating power in the form of light and heat, 200 watts. The light bulb will shine at its brightest and it will use up 200 watts. If we now move the slider of the rheostat towards the A end of its resistor, the current will have to flow through the 50 ohms of the rheostat and on through the 50 ohms of the light bulb. In other words, we will be applying 100 volts from the alternator to the 100 ohms made up by adding the rheostat and the light bulb in series. The current flowing in this circuit will be 1 amp. 1 amp multiplied by 100 volts being applied to the circuit will add up to a total dissipation of 100 watts. This amount of power is distributed among the two items so that both the light bulb and the rheostat will each dissipate 50 watts. We will be getting 50 watts of light in the light bulb, but another 50 watts will be lost in the resistance of the rheostat in the form of heat, a loss of energy which is also coming from the alternator, and we will still have to pay for it. Another drawback is that if we mount the rheostat on a rack or some sort of a cabinet, the heat generated will overheat the cabinet, the cables, as well as the knob used to control the rheostat. The larger the light bulb, the greater the heating of the rheostat, cabinet, and wiring. One solution would be to use an electronic dimmer. This device can control the power without having to waste its heat in resistor. For the purposes of this basic explanation, we will say that the dimmer has a circuit that, with each alternator of the current, produces a small pulse which can be manipulated by means of a knob, so we can use the full alternation or just a portion thereof, acting as a high-speed switch which renders the effect of controlling the voltage applied to the light bulb. Since it is a fast-acting switch for quickly turning the power applied to the bulb on and off, it does not produce but a negligible amount of heat. This type of switch can be applied not only to dim lights, but to control the speed of drills, sewing machines, mixers, etc. As to motors, two types are mainly used around the home: brush and commutator and induction motors. Constant speed appliances are equipped with induction motors, the speed of which is set mainly by the frequency of the AC from the electricity company. Brush and commutator motors are used in almost all other household appliances. So much for this section. In the next one, I will talk about green energy applied in the home. I hope this video has been useful to you. Please follow the series and subscribe to my channel. Chava Tarin.